Okay, our job is to look at each of these pair of triangles, decide if they're congruent, and then if they are, we're going to create a flowchart proof to prove they're, I said congruent, I meant similar. So check if they're similar. If they're similar, create a flowchart proof. So we'll do the first one together, and you'll be responsible for the other three. So look at this first one and tell me, do you believe, first of all, that these two triangles are similar? Yes? Yeah, we got a gut belief that yes, they are similar. Great. It would be awesome if we had a reason to state that they were similar. Sorry, well, this thing is focusing. Angle, angle. Oh, come on, you can do it. There we are. I do see a pair of angles and another pair of angles. We could do angle, angle. Could we do side, angle, side? This triangle has side, angle, side, but do both triangles have side, angle, side? We do not. We do not. This one has one side. I would need another side. Like I would need this side over here. I need a number here in order to pull off side, angle, side. We could solve for it, not until we've proved that they are similar, but once we prove they're similar, then yes, we could solve for it. Yes. Okay, so let's go ahead and do this. We said we're going to do it with angle, angle. I'm going to start, as I usually do at the end of my proof, because I know what I'm trying to prove. I'm trying to prove that these two triangles are similar. What do you want to call the top one? ABC, BAC, CAB? ABC, we'll keep it alphabetical. We want to prove that ABC, triangle ABC is similar to triangle. Now let's match them up. A had the single tick mark. A had the single tick mark, so A needs to match up with D. And then B had the double tick mark, so B needs to match up with E. And C had no tick marks, which needs to match up with F. So A, B, C, D, E, F. Now, if you had the A, B, C in a different order, of course, your D, E, and F would also be in a different order. And you guys said what reason were we going to use for this one? Double A. Double A similarity with the squiggle. Okay. While we're here, just out of pure transparency, I want you guys to be able to anticipate how I'm going to score you on your test. If you wrote this and you left the little triangle symbols out, that's going to cost you points. Okay. If you wrote this and you left the AA off of it, that's going to cost you points. If you wrote it and you left the little squiggle off of the AA for the similarity piece, that would cost you points as well. So just be careful of those little details. Get into good habits and practices now while you're practicing, and then you won't have to worry about leaving those things off. All right, we're doing AA, which means I need two pieces of evidence to flow into this conclusion to support it. So I'm going to go ahead and draw myself a couple of bubbles. I need two because basically you need one piece of evidence for each thing in your reason. Angle, angle. I need two pairs of angles, and I need to show that those angles are congruent. So I got a pair of angles here, angle A and angle D, so I'm going to say the measure of angle A equals the measure of angle D. And then there's one other pair of equal angles that I'll let you guys find. The other pair is B and E. All right. When it comes to the little M's in front, if you leave those off on this test, you will lose points because we haven't really talked about why that's important. We'll talk about that more in the second semester when we get into congruence. We will eventually. So that will be important right now, but I'm not going to take points off if you leave the M's off right now. Because we really haven't discussed that yet. However, I do want to see those angle symbols. So don't just say A equals D and B equals E. That would lose you some points. Not the whole thing, but small points. Do we need any additional evidence to back up either of these two things? Right, so basically we didn't have to do any extra work to know that these were equal, did we? We did not. We didn't have to do any extra work to know that these were equal. It was already given to us in the original picture, so we didn't need any extra work. I want to remind you, When we put together a similar proof last week, we did need a little bit of extra evidence because when we first looked at this picture, we didn't know that this was 22.3, so we didn't know it was going to match up with this one. We had to do a little bit of work, which is why we had to include that extra bubble. Right? All right. So your job then is to go through and decide, is this next one a picture of two similar triangles? And if so, go ahead and set up a proof. As a reminder, if you end up using side angle side, big spoiler hint here, if you end up using side angle side, your proof's going to look a little bit different. It's going to look like this, which is on the previous page. So use this as a model if, wink, wink, you end up using side angle side for one of these. And I will tell you that one of these on this page is not, they're not similar. So you're only going to end up making 3 proofs. All right, get after it. Ask me some questions if you got them. I'll be here to support you. All right, hey, we're going to keep going, folks. Shh. Yes, I will definitely do that. If you are already done with these, please check and make sure. I know I need to still stamp people. I will get to you, I promise. I just want to keep the bus moving here so you guys can get some time to work on your assignment. As I'm looking at this one, what I'm noticing is I got a pair of matching angles here, and then I have some sides on either side. So I think I might be able to do side angle side. Could I get you guys to pause your side conversations? Thank you. That's only going to work out if my ratios end up working, so I'm going to check those first. So I got 12 and 9 that would match up. By the way, how do I know the 12 goes with the 9 and not the 12? Can I get your attention, please? Because 16 and 9 aren't the same? That's one good reason, yes. How do I know that 12 goes with 9 and that 16 goes with 12? Yeah, so these are the 2 smaller sides and these are the 2 bigger sides. So you can go based on the relative sizes. So I'm going to go 12 over 9, which ends up being 1.3-ish. Is that right? 1.3 repeating. And then when I do 9 over 16, is that the same? Yep. 1.3 repeating. Okay, so we are set up to do side angle side. So let's start with our conclusion. Can you close that door for me, please? Do you mind? We'll get to that question in a moment. Okay, so let's address that now. What if we use measure of angle G and K? I don't have any information about angle K. I don't know. I have no idea how many degrees it is right now. Okay, I can't assume that it's the same as this until I've proven that they're similar. So we can't use these because I just don't know. There's not enough information and there's no way for me to know until I know that they're similar. Now, once I've proven my triangle similar, then I could come back and say that K is going to end up being 53.1. But we can't use evidence that we haven't proven yet to prove the thing. Does that make sense? Then our proof would be circular. Okay, question. Yep. It should be 16 over 9. Thank you for correcting me that. And I'll make sure I get that right when I put it in my proof. Okay, let's do this. Triangle HIG, yours may have been different, but H should match up with L, I should match up with J, and K should match up with G. And I think I'm going to use side angle side similarity. Side angle side similarity, there's a specific format that these are going to use. We're going to have a bubble here that's going to be talking about my 2 sides, my 2 pairs of sides, and we'll have evidence flowing into each of those. Colton, it's a now. Grab this on your way out, please. Let's do the evidence bubbles up here first. So this is where I'm going to use my 2 ratios. So 12 over 9 is 1.3 repeating. And I won't flip it this time. Thank you for catching that. This should be 16 over 12, shouldn't it? Why am I keep writing this wrong? 16 over 12 equals 1.3 repeat. I'm sorry. Thank you for your patience. I appreciate your patience. And then what goes in this bubble are the names of those things. So for example, the 9 is on the bottom. The name of that side is LK. 9 was between L and K. So KL or LK, it doesn't matter. And then the 12 that we matched it with was here. That was HG. Over here we had 16 and 12. The 16 was the HI. Have a good day. And the 12 that we matched the 16 up with was JL. Now you could have flipped those two fractions if you had them, if they were both flipped on upside down, that's fine. If they were both flipped upside down, then these would be flipped upside down here as well. Did anybody, instead of doing 1.3, was anybody getting 0.75 because you divided the other way around? Yes, that's fine. That's fine. So if I had done 9 divided by 12, it wouldn't be 1.3 repeating. It would be 0.75. So you would have different numbers here, and then these would have been flipped in yours, right? It's totally fine. All right, then I also need my pair of angles, and that would be L and H. So the measure of angle L is equal to the measure of angle H. And I'm just going to do a quick checklist. I'm trying to use SAS. Do I have 2 pairs of sides? Yes, I dealt with the 2 pairs of sides right here. Do I have my angle? Yes, I dealt with the angle here. There's my flowchart. Any questions on that one? Can I get everybody to please check your flowchart right now and make sure that it is set up, that it looks something like this? If you would like me to look yours over specifically for errors, I'm happy to do that. Okay, make sure you're following the rules. Make sure that your evidence are moving down the page, that you're drawing arrows from your evidence bubble to your conclusions. Does anybody have any questions about that one? All right, this next one turns out is not similar, because if we start making ratios, if we do 14 over 7, that's 2. If I do 8 over 4, that's 2, but unfortunately, 9 over 5 is not 2. It's 1.8. So these triangles are not similar because the ratios don't match. So we would just write not similar. And the last one. For me, this is going to be easier if I split these 2 triangles up and deal with them separately. I've told you guys to do this several times. I'm hopeful that you guys are spending the time to do this. It's just going to make things so much easier for you. 9 and 2.5 is 11.5. This would be 5 here. This is 9 and 11. And then that's all we got. I also have these 2 angles congruent, and since this angle came from the same place as that angle, those 2 angles are congruent. So this is an angle-angle proof, because both of the triangles have the same angle M. So I'll write quickly what the proof is going to look like, and I'm going to point out a common mistake. If you're looking at your own proof right now, could you please check and make sure that you did not talk about angle S? You may not use angle S in your proof. You can use angle NSM or MSN, but you cannot say angle S because there's more than one angle happening at S. Okay? Now, only one of them is marked, but there's more than one there. When you look at the original picture, there is an angle right here, and there's an angle right here. And there's actually a third angle that's a 180-degree angle that consists of both of them. When you have more than one angle at a point, you cannot use a single letter. You have to use 3 letters. Now, V is okay. If you talk about angle V all day, because there's only one angle you could possibly be talking about when you say angle V. But we can't talk about angle S because I don't know if you're talking about this one or this one. Okay, so just make sure you're using 3 letters for that. All right, so triangle TMV is similar to triangle NMS. We've got SS similarity, and we just need two bubbles, one for each pair of angles. So I'm going to say the measure of angle V. Sorry, that should be AA. Thank you. There is no SS. A measure of angle V is equal to the measure of angle, and again, I can't say angle S, but I can give it three letters, N, S, M. And then this was going to look weird, but the measure of angle M, wow, my brain is doing weird things today. The measure of angle M is equal to the measure of angle M. All right. I know that this is new for us. I anticipate that you probably had some mistakes in one or both of those proofs. That's okay. This is how you're going to learn. There is no like step-by-step process to these. A lot of these proofs look similar for now, but when we get into the second semester, every one of these is going to be different. The formatting is going to be different. They're all just going to be a little bit different. The best advice I can give you right now is start at the conclusion, work your way backwards. Ask yourself, what evidence did I need to use AA? I needed two pairs of angles. All right. Any questions there? You guys are doing awesome. That was one. We got it in us. Let's do one more.